Good day. So we are given the diagram, and the diagram we are given three blocks. These blocks we are simply placed on this table, and the first block we are given the mass of it to be 15 kg, and the other block is 6 kg, and the last block is given as 10 kg, which is 10 kilograms. And the purpose of this question, we are required to calculate the acceleration, and the next point to calculate the tension in the springs. We need to calculate the tension that acts along the spring. We also need to calculate the tension that acts along the spring. So those are the three things we are required to calculate. The tension here and the tension here. And the last point, we are also asked to calculate the acceleration. But in this point, we need to calculate two cases or 2 points. The first point, we need to try to indicate all the forces which will act on this body. If we indicate all the forces that will act on this body, it will be very easy for us to calculate what is required for us. That's the first point. And the second point, we try to draw the diagram or resolve this table or this table alongside the blocks in a simple way, wherein we can able to identify the forces which act on the table. Starting, if we implement those two things, it will be easier for us to calculate what is required from us. So the first point, we need to draw the diagram and we indicate all the forces which act on the table. That's the first point. And the second point, we'll do the needful. So if we do that, let's redraw this diagram. If we draw this diagram and identify, so this is the diagram. So we have these forces being placed here. So this is 10 kg. So we have this mass that is being attached here. This is 6 kilograms. This is mass M2. And we also have another one which is being attached here. So this object is mass 15 kg and if labeled as M1, this is labeled as M. So this is it. So we need to identify the forces that will act on this object. So if we identify the forces that act on this object, if we compare the two forces, this mass given here is mg and it's 15 kg, and the mass given here is 6 kg. So simply the mass here is greater than this. So this object will be pulled towards this side because this is greater than this. So if this is being pulled towards this side, you need to know the direction of the forces. So if this is less than this, it's simply this object will be pulled towards this side. So it's being pulled towards this side. Therefore, it means the tension here, this is M2, the tension is going to be T2 will be greater than the weight. So this weight, M2 is going to be M2G. Here again, let's indicate the weight. The weight here, M1 is going to be M1G. This is the tension T1. Here again, the tension T1. This is the tension T2. Mind you, we are given the drag force, we are given the coefficient of friction. Since we are given this coefficient of friction, it simply means there is a drag force along this diagram. It's just like if you are pushing a box or an object, the force which slow the movement of that object is what we call the drag force, or in another way, we call it to be the frictional force. So the drag force here will move towards this side because since this object is being pulled towards this side, there is a drag force that will tend to pull it again to the other side. So let's identify that drag force to be F. If that drag force is identified to be F, I think this object, this body is being placed on this table, so its weight will act downwards. So the weight of this object, W, is going to be mg, and there's going to be definitely a normal reaction that will act. So that normal reaction is going to be R. So we have this. So I think we have these forces. So since we have these forces, we can resolve the diagram in a simple way. If we consider this force here, this force, let's have it here. So if we consider this force, let's say this force 6 kilograms, let's have it here 6 kilograms. We consider this and we consider it R. So this is 6 kg and its mass is M2. The weight here is M2G. But we know since this is smaller than this, it will be pulled this way. So therefore, this weight W2 is less than T2. So it's going to be T2 minus W2. So you see, but in this case, we need to find the net force as I illustrated. Net force or which you can also call as the resultant force. Let's consider this object. If this object is labeled as F1, this other object is labeled as F2. So the net force here is going to be F1 minus F2, provided F1 is greater than F2. If this force is greater than this, so the net force is going to be this minus this. Always the net force is going to be the greater force minus the smaller force. Or if F2 is greater than F1, it's going to be F2 minus F1, provided F2 is greater than F1. So this is how we find the net force or the resultant force. You see, so it's the same thing. So in this case, since this is T2, and this object is moving upward, it's simply the tension is greater than its weight. So the net force here, net force is going to be T2 minus M2G. For the net force, now going to be M2A. M2A is going to be T2 minus M2G. So this is going to be equation 1. We've also consider these other forces. This other force again, because since in this case, this 15 kilograms is greater than this, so this mass will move downwards. So its weight is greater than the tension. So it's going to be the net force for this second one. The net force for the second one is going to be M1G minus T1. M1G minus T1. But M1, this net force is going to be M1A, going to be M1G minus T1. This gives us equation 2. We've also considered this block. This block, I think, let's draw it so we can see it clearly. This is the block given. We have the block which placed on top of this table. This is T1, and we have the tension T1, T2. We also have this force, the drag force. So this is M, or 10 kg. So the net force for this, net force here, definitely is going to be this force, because this 15 kilogram is greater than this 6. So this object will be pulled this way. So this tension is greater than this other side. So it's going to be T1 minus T2 minus F. So what net force now is going to be in terms of M, so it's going to be MA, is going to be T1 minus T2 minus F. This gives us equation 3. You can also consider the vertical force, which is R and M. So R equals to W, R equals to W, but W now is mass times the gravity, which is mg. This equation 4. You see, this is it. But we are also given this drag force, which has a coefficient of friction of 0.4. So the drag force now, which is the drag force, equals to the coefficient of friction times the normal reaction. So you're going to be R times, what is normal reaction? Is mg, so you're going to be mg. So this gives us equation 5. So I think these equations, we can use them now to calculate the tension T1 and T2, and as well as A. So having these values, we can consider the equations. Let's say we add equations 1, 2, and 3. So if we add these 3 equations, equation 1, we have it to be M2A equals to T2 minus M2G. And we have equation 2 to be MA equals to T1 minus T2 minus F. And also have equation 3 to be and equation 2 to be M1A equals to M1G minus T1 minus T1. So let's add these 3 equations. So if we add these 3 equations, here A is common to factorize A, so it's going to be M2 plus M plus M1 equals to, here if we look at this, let's look at them carefully. Minus T1 will cancel T1, and minus T2 will cancel T2. So what will remain? The terms that will remain is going to be minus M2G minus F and D. So say M1G minus M2G minus F. So make A the subject, so it's going to be this M1G minus m2g minus f divided by m2 plus m plus m1. This is what we have. You see, but mind you, we have our f to be the coefficient of friction times mg. So if slotted, so we have m1g minus m2g minus mu mg divided by m2 plus m plus m1. This is the first quantity, so this is A. So if you are required to find A, since we have the values for M1, M2, M, G, and mu, we can just plot them. But G is not given. You know, G varies. Since we are on Earth, G, we can take it as 9.8 meters per second square, or we can take it as 10. Because if we consider for like the mass, we can take it to be, because the mass we can take it to be 3.71 meter per second square, while for the moon we can take it as 1.61 meters per second square. So those are just various values for the gravity. But since on Earth here, we can either choose 9.8, we choose 10. We can slot them here and we'll find the value of the acceleration. So with respect to that, since we have A, our next point, we try to find T1 and T2. So what will be the next point? How can we find T1? Let's look for T1. We'll take equation 2. We say from M1A, we take this equation. It's going to be M1G minus T1. If we make T1 the subject here, going to be T1, going to be M1G minus M1A. So you see, so we have T1 is going to be M1G minus M1 into, what is A is this? We've slotted, but here we factorize G, is going to be G into M1 minus M2 minus mu M divided by M2 plus M plus M1. This is it. So if we continue T1, right, if we continue T1 is going to be, so I think let's bring it here, let's clear this part. So T1 is going to be, here we can find the LCM. So you're going to be the denominator, which is M2, because the LCM here is going to be M2 plus M1 plus M2 plus M plus M1. Because this is just all over 1 into this time is just going to be this. It's going to be M1G into M2 plus M1 plus M. And we have our minus sign, minus M1G. Because this into this is just one time this top is just the top, which is M1 minus M2 minus mu M. So we expand, it's going to be M1G times M2 is going to be M1 M2G. M1G times M1 is going to be M1 M1G. M1G times M is going to be plus M1G. We are done with this. Minus, we'll take this again. M1G times M1 is going to be M1 M1G. Minus will be plus. M1G times this is going to be M1 M2G. Minus is plus. So the last one, M1G times mu M is going to be mu M M1G divided by M2 plus M plus M1. So if we simplify, if we look at the terms, let's see, M1G plus M1M, these two terms will cancel. Because M1M, so M1M2G, we have it here. No, this will cancel M1G will cancel M1G. This is M2G, this is M2G. So if we add M1M2G plus M2M2G is going to give us 2, because this and this will cancel. This plus this is going to give us 2 M1M2G, and it remains this plus M1G, it remains this plus mu M1G divided by M2 plus M plus M1. So this is what we have. So if we factorize G, it's going to be 2m1 m2 plus m1 plus mu m1 divided by m2 plus m plus m1. This is a value, this is the relation for T1. So we have T1, we also have A. So we can easily go for T2. If we have T2, we are done. So we find what we are equal to. So if we go for T2, we can consider this equation to find T2. We consider this equation. We say from this equation, which is M2A equals to T2 minus M2G, think we can clear this for now. If we make T2 the subject, so T2 will be M2A plus M2G, because if we transpose, it's going to be T2 equals to the sum of this. So if we substitute now, T2 going to be M2 into what is A? And A is this. A is just G into M1 minus M2 minus mu M divided by M2 plus M plus M1 plus, write our M2G is it. So we'll further continue, we'll say M2 equals to, we'll find again the LCM here, it's going to be M2 plus M plus M1, this into this time this is going to be M2G into the top, M1 minus M2 minus mu M, plus this into this, because this is just 1 into this is just this time this will just be M2G into M2 plus M plus M1. So think we don't need this again. So if we, our A, let's just extend here. So if we continue, we simplify this, T2 is going to be M2G times 1 is going to be M1 M2G minus M2G times this is going to be M2 M2G minus M2G times is going to be, we have our coefficient of friction mu, and we have our M, we have our M2, we have our G. So we are out of this bracket, we'll come there again, plus M2G times M2 is going to be M2 M2G, M2G times M is going to be plus M M2G, M2G times M1 is going to be M1 M2G, all divided by M2 plus M plus M1. So T2 now is going to be, so we look terms which are common. If you look at M2 M2G, M2 M2G, so this plus will cancel this minus. I think those are all the terms that will cancel. So if we have now M1 M2G, we have M1 M2G, so we have, it's going to give us 2 M1 M2G. So we have this minus mu M M2G, and we have plus M M2G divided by the denominator divided by the summation of the 3 blocks, M2, M plus M1. So therefore, T2 now is going to be, G is common, because G is here, we also have G. So factor G, it remains 2 M1, M2, minus a factor G, it remains mu M, M2, and a factor G, it remains M, M2, divided by M2 plus M plus M1. So these are the values. So we have our values M2, we have T1, T2, and A. Since we have these values, we can now find the respective values for A, T1, and T2. So if we want to find A, T1, and T2, let's just rewrite them here. Let's write A. So what is the expression for A? Oh, A, I think we cleared it, but we can have it here because we started the A is this, or we can have it here. A is G into M1 minus M2 minus mu M divided by M2 plus m plus m1. What's going to be the value for A? And T1, we have T1 to be this. We say G into 2m1 m2 plus m1 plus mu m1 divided by m2 plus m plus m1. So what's going to be the value? So what about T2 again? For T2 again, the same thing. Look at it here. G into 2m1 m2 minus mu m2 plus m2 divided by m2 plus m plus m1. What's going to be the value? I think this is what we need to find. So we'll start with for A, the aspiration, we know we consider we consider this gravity to be 9.8 meters per second square, G to be 9.8. So if that is considered, we take G to be 9.8, we say 9.8, bracket open, M1 is, let's not forget, M1 was 15 kg, and M was given as 10 kg, and M2 was given as 6 kg. So we have to take note of these values. So M1 here is 15, we say 15, minus M2 is 6, minus mu is 0.4 times M is 10, divided by bracket open 10 plus 6 plus 15, bracket close. So we have the acceleration to be 1.58. So the acceleration there is 1.58 meters per second square. This is the value. You see? So if we go again for the second value, T1, the same thing, G is 9.8, bracket open, 2 times M1, which is 15, multiplied by M2, which is 6, plus M is 10, times M1 is 15, plus mu is 0.4, times M is 10, times M1 is 15, bracket close, divided by bracket open, M2 is 6, plus 10, plus 15, bracket close, and so we have something like 1, 2, 3. So the answer, so T1 value is 123.29 Newton. This is the force for T1. You see. So if we consider again for T2, what's going to be the force for T2? The same thing, G is 9.8 into 2 times M1. M1 is 15 times M2 is 6 minus 0.4 for mu times 10 times M2 is 6 plus M is 10 times M2 is 6, bracket close, divided by bracket open 10 plus 6 plus 15, bracket close. So this is 68.28 Newton. So these are the values. So the acceleration due to gravity, which moves the object, is 1.58 meters per second square. It simply means that the acceleration for the block is 1.58 meters per second square, and the tension T1 is 123.29 newtons, and tension T2 is 68.28 newtons. So these are the required values we are required to find. Thank you and stay blessed.